Hello everyone, we will solve this today's LeetCode problem. This is subarray with k different integers. I think this week is of for sliding window only. This question is also of sliding window. Let's see how we can solve this. So this is a hard problem, but why it is hard? It is something a twist in this problem again. That's why it comes in hard problem. Otherwise, if you just think of logically, then you will see that this is a simple sliding window problem which has which is similar approach than all the three problems which we have solved previously. If you don't have watched, then please watch. So there's given an array integer nums and integer k. Return the number of good subarrays of nums, and a good subarray is an array when the nums of different integers is that in that array is exactly k, right? So we need to find the number of good subarrays of nums. And what is the good subarray? In subarray where different number of integers is exactly k occurs, right? So I told you already that whenever we get subarrays or good subarrays, count of subarrays, anything, you first think of hashing subarray, hashing sliding window, this type of approach, right? So let's see how we can solve this. This is 1 to 1 to 3 given, and k is equals to 2 is given. So we need to find the number of good subarrays from this given array, in which the number of different integers in that subarray is exactly k, which is 2. Let's see how many integers are there, subarrays are there. So here nums is given 1 2 1 2 3. So if we see this 1 2 can be an answer, right? This 1 2 1 can also be an answer, because there are two only different distinct integers. There can be 1 2 1 2 can be also be the answer, because there are only two different integers. So if 1 2 1 2 is an answer, then 2 1 2 can be also an answer, then 1 2 can also be an answer, right? So but we can't take this whole array, because this is at three different integers. So we can't also take 2 1 2 3, because it's also three different integers. But we can take 2 3, right? So if you see that total number of subarrays are 7 here. So at first point of time, you will get stuck at how we will approach this using sliding window. So let's see how we will approach this, right? So here let's see, can we apply sliding window in this, right? So what we will do in sliding window, we make a window here, and simply we shift that window till we get this exactly number of k. So how we will track this number of different integers? By taking a hash map, or by taking unordered set, right? Unordered not set, multi-set. We need to take multi-set, because if you take unordered set, that will store only number of distinct integers, not multiple times. That will occur an issue. So either you can take a multi-set or unordered, right? So let's say for tracking this, right? For tracking distinct integers. So let's see for 1 to 1. So if we go through the simple approach, like we make this windows, like we stored this 1 in my nums, 1 count, this 2 count, again 1, but count will be again 2, number of distinct count, that will again 2, this 2, that will be again 2, right? So if you see, the number of distinct count is 2 here, and still it is then we will store this in answer. My answer will be this, answer plus plus. We will do this, and when we store again this one, we will have again my answer. But you will lose this subarray, right? If we just count, we get this subarray 1, again we get this subarray 1, then we again got this array. We will lose this subarray if we only do plus plus. So but if you think the previous one, like we will do simply when we get the number of distinct subarrays equals to number of integers is equals to k, then we will simply store that in my answer. Suppose this you do plus plus here. Now you will do, whenever you get again this array, you will again mark second, and when you got here, you mark plus plus, increment this answer. But you will miss this subarray, this subarray, this subarray, right? So what can you think? So one approach is come in mind that whenever I get the distinct number of integers equals to k, I will simply count all the distinct integers in that window. But if you do so, you are not confirmed that whether it's all previous subarrays have exactly k elements, right? Because it is not given less than k, it is given exactly k. So you can't simply store jth value, right? Suppose you come here, you store j minus I plus 1, you come here, you store j minus I plus 1. Till here all things fine. But when you come to this, you can't store j minus I plus 1. Why? Because if you do so, you will know that this is only a one subarray, this is not an subarray, right? So you can't do this. So for different is exactly k, what we can think, right? So can we think of, like, we will solve for less than k and greater than k, something like that? Can we solve for less than k? Let's see. Whenever we get number of distinct integers less than k, we will simply store j minus I plus 1, right? For less than k, let's see, this is the less than k value, right? What we can do for less than k, we will simply go to this numbers, and whenever whenever we get the subarray and the distinct number of different integers less than k, we will simply increment our answer, right? Suppose we come across this one, so that will be that can be an answer, so we will increment my answer 1, right? When we come across 2, it is equals to 2. So let's take a different example, right? This is very small example. Let's suppose this is k is equals to 3 given, and this is 1 given, this is 2 given, this again 2 is given, this is 1 given, now this is 3 given, now this is again 2 given, and let's suppose this, right? Now for less than 3, how many numbers of subarrays are there? Let's see. 1 can be the answer, again 1. Now we can store 2. Why? Because this 1 can also be answered, and this 1 comma 1 it can also be answered. So there are 2 subarrays. Now this 2 here, this is less than 3. Now again 3 can be answered, because this 2 can also be answered, this 2 1 can also be answered, this 2 1 1 can also be answered, right? We again get 2, we can again store 4. Why? Because all this can be an answer, right? All the subarrays till this can be an answer. Now when we get 3, it is not less than k, it is equals to k. Now we need to shift the window. Now we will start from the j is equals to 0th pointer and start decrementing it. We will remove this one, again this is 3 distinct integers, right? Now we will remove this one. Now this 2 to 3 has only 2 distinct integers, which is less than k. So what will be the answer? So answer can be this 3 also, this 3 comma 2 also, and this 3 comma 2 also, 2 comma 2 comma 3 also, right? So what will we store? Now jth pointer is at here, so we will need to store the j I minus j plus 1. Why? Because you need to store these 3 answers, so I minus j plus 1, that will be the only answer. So for less than k, what will we store in my answer? I minus j plus 1 whenever we get the number of distinct integers less than k, right? Let's see for greater than k, right? Let's see for greater than k. So for greater than k, let's see, this is 1, number is 1 distinct integer, again 1 distinct integer, two distinct integer, two distinct integer, three distinct integer, it is still less than it is still not greater than k, it is equals to k, right? Two distinct integer, three distinct integer, three distinct integer, three distinct integer. So the number of subarrays which is greater than k is 0 only, right? We don't have any numbers which is greater than k, right? So let's suppose, but here it is given 4, let's suppose we change it to this 4, right? And now this 4, this 3. Now what will be the answer for greater than k, right? So till here there are only 3 subarrays, 3 distinct numbers, but when we get this 4, we have 4 distinct numbers which is greater than k. So what will be my answer? So till here there are 4 distinct arrays, 4 distinct numbers, so this can be my subarray. So after that, don't you think that after this number, whichever elements I choose, at least there can be 4 distinct integers, which is which can be also greater than 4, but at least there must be 4 distinct numbers in my subarrays. Either we will choose this, either we will choose this, either we will choose this, or either we will choose this, right? So can we tell that the number of distinct subarrays whenever we get a number greater than k, that will be n minus I. Why? And by n minus I, this is ith index, and total number of nums array is n, then n minus I, which is equals to this 4, right? 1 0 1 2 3 4 5 6, this is 6, and total number so is 9, so 9 minus 6 plus 1 is 4. So answer will be the first 4. So what will be stored in my answer? N minus j, right? N minus j, simply, right? And what will be my and for exactly calculating for exactly k, what we will do, we will count total number of subarrays and we will minus less than k, and we will also minus greater than k. So that will be equals to my exact total number of subarrays, which is exactly equals to k. So that will be my answer here, right? So this is the this is how we can solve this problem, right? So what will be the time complexity of this? So for calculating this less than k, we need to take O of n iteration and an ordered map for tracking it, and for greater than k, we need to take O of n and an ordered map. So total it will be O of 2n, and for we are taking only an extra array in less than k, which will be deleted after that, and we will again use greater than k, which will again delete that. You can take O of 2n, which is space constitutively O of n, and the time constitutively again O of n. So let's see this, how we can solve this. So let's do this here. So let's make an extra subarrays, or don't need to do that. Let's suppose this is less than k, and we just pass this arrays and this k here, right? So this is nums dot size. For calculating less than k, what will we do? We will this is for storing answer, and I will take unordered map for tracking the number of distinct integers. So we will start iterating in my loop, and what we'll do, I will simply store the integer in my array, and what I will do, I will check if this size is greater than equals to k. Then what we will do, we will simply decrement the jth pointer. Okay, I need to also maintain a jth pointer, which will start from 0, and I will decrement this jth minus, right? And I will increase this j plus. But I also need to check whether this nums j value is 0 or not. If it is 0, I need to delete this, right? then I can only decrement this size value, right? And also need to maintain a condition for jth less than I, because if it is greater than, then there is compulsion that that element will be not be in my unordered map. And what will I store in my answer? That will be I minus j plus 1. Why? We have already seen here that we need to take all the its previous elements, because that will always be less than j. Or if you are not satisfied, then you can simply uh, mark this condition as less than k, although it's not needed here, but still for extra security. And we just run this answer, right? Again, for greater than k, what will we do is we will simply mark this as greater than k, which is, we also solve for this greater than k. In that, what we need to change, we are taking for greater than k, right? So whenever we get greater than k value, I will store my answer. I will store the answer. What I will store, we have seen that we will store n minus j till from that element, from that index to, from that index to, what will store from that index to the end of the array. That's why I have minus n minus I, the and just simply all the process will be the same, and we will simply return answer. So after that, we need to calculate this total value, total number of arrays exist. And what will be the total number of arrays? N into n plus 1 by 2, and we will simply return total minus this less than k nums k minus this greater than k. Okay, so this will be greater than k, right? So this will be greater than k, and this is, yeah, right, this is same. This is nums, and this is again k. And I think that's all good. Let's run this. Here, this is, there was some network issue before, so let's run this. Yeah, this is test case pass. Let's submit it. So yeah, we have passed all the cases. But if we see that this is very lengthy, right? We need to do iteration, and we while solving this, I just got an approach I got while making this video, that what if we simply uh, what if we simply uh, find the total number of arrays for the numbers which are less than or equals to k, and also one number of arrays which is less than less than k, and we simply minus, let's suppose this is a and this is b, and we simply minus a minus b. So don't we get the number of subarrays equals to k? I think that will also work, right? We will find less than or equals to k for so this, so less than equals to k, and we will find less than k, and we will minus this from this to, we will get equals to k, right? So we don't need to find this greater than value k, so we don't need to maintain this extra nums, this extra function here, right? We don't need to find this for the greater than value k, we will just need to find less than. So what will be the changes? We just do this k minus this k plus 1 for this one, and this is k, and we will just do this. I think that will also work. Yeah, I think that will also work. We will just calculate for less than equals to k. So for we have calculated for less than k, so we need to do k plus 1 for calculating less than or equals to k, and we will minus this for less than k, and we will get this equals total number of arrays for equals to k. I think that will also work. Let's see this. I just got an idea while making this video, but let's see. Yeah, I think this is passed. This is, let's submit it. Yeah, bingo, we have passed this case. So we don't need this greater than, right? So what we can do is we need only this less than equals this one function for less than k, and we will just calculate for less than or equals to k, and we will just minus this less than k value. We will get number of arrays equals to k. Bingo, we got another approach here. So yeah, that's nice. So we reduce it from O of 2n to O of 1, O of n, sorry, my bad, O of n, and the space complexity will be still of O(n) because we need to maintain a number of distinct integers. For that we need to take a map. So yeah, we have achieved time complexity O of n, and the space complexity is O of n, right? So yeah, I think we are good to go. Thanks. This is second approach.